Lovely greetings to all students. We are here to solve the JEE Main question paper that had been asked on 2nd September 2020, and the shift that I have is the evening shift. Let us begin. And the first question is from electromagnetic wave. You must be knowing electromagnetic wave is present only in JEE Main syllabus and it isn't there in JEE Advanced. So if you observe the question trend of the examination, there are certain chapters which are there only in JEE Main, and specifically from these topics, questions are generally asked. The probability is very high. Now you could say the first question comes here. It's a straightforward question though. The electromagnetic wave, the direction of electric field and magnetic field, that's given by k cap and 2I cap minus 2j cap. From this, we need to calculate the unit vector along the direction of propagation of the wave. So what we'll do here is something like this. The E cap, the direction of electric field, that is k cap, which is straightforward given there. Then the unit vector along the magnetic field, that's going to be 2I cap minus of 2j cap divided by root of 8, or further 2 root 2, you can write that. Next what? E cap is known, B cap is known, so quite obviously the direction of wave, we know by the expression, is E cap cross of B cap. And once you do that, that's a very straightforward one. That will give us option number 3 as the correct answer. All right, let's move to question number 2. Question number 2, that's from Wave Optics, YDSC. And it's a very straightforward one. It says, in a certain segment of the screen, initially 16 fringes are there when the wavelength was 700 nanometer. And let me represent this by N1 and this 700 nanometer by lambda 1. In the second case, the wavelength has been changed and that is lambda 2. And we need to see the number of fringes observed in the same segment. So straightforward, what we can say is that the fringe width, of course, that is lambda 1 d by small d, that's a fringe width multiplied by the number of fringes. That will give me the span of that segment in which these many fringes are there. And for the same segment, we need to see the number of fringes with the wavelength lambda 2. And now, a straightforward calculation will give you option number 1 as the correct one. Let's go to the third question. The third question is something like this, related to thermal expansion. When the temperature of a metal is increased from 0 to 10 degree, the length increases by this much. So what is 0.02%? That is, of course, the change in length, the percentage change, and that comes out to be 0.02%. All right, so that's a percentage change in length. And you also know that this particular percentage change can always be related to delta L by L equals to alpha delta theta. So that's how you can straightway use the concept. Now in the same regard, we need to calculate the percentage change in its mass density. Now you could see when it comes to the percentage change in density, it's delta rho by rho, and that comes out to be minus gamma delta theta, negative sign indicating the density decreases. And now since the value of gamma is equal to 3 alpha, so straightforward, the percentage change in mass density is going to be how much? 0.06%. So that will give option number 2 as the correct one. Let's see the fourth question.